Okay. Good day, everyone. Before we continue, I would like you to like and subscribe to my YouTube channel. And today we are going to be looking at solving more complex quadratic equation. That means that it look like we have been solving quadratic equation. That is true. For those of you that are new to my channel, you can watch my old videos. You see where we solve quadratic equation using different methods. Today we are going to be looking at compression. A brief recall that quadratic equation I told you must be in form of a must be in form of a x squared plus bx plus c equals to 0, where a must not be equal to 0. So any other part can be equal to 0, but a must not be equal to 0. So that being said, whenever you see the highest power of the variable here, that is 2, then I, um, then it's a quadratic equation. But when we can look at this particular question given there, the question states 4x raised to the power 4 and 4x raised to the power 4 and minus 17x raised to the power 2 plus 4 equals to 0. Now, this almost looks like quadratic equation, but the highest power of the unknown is 4. So we have to look for a way to make it to be in form of quadratic. The first thing I want you to do is that whenever you look at something like this, equation that look like quadratic equation, but it's not quadratic equation, check the number that's supposed to be the variable that's supposed to be just x that does not have a power. Check, can it be the multiple of the first one? Like, for example, let's look at this. This thing can be in form of 4x raised to the power 2 in bracket square minus 17x squared plus 4 equals 0. Now, this particular thing, according to the law of indices, when you have a raised to the power 2 in bracket 3, is going to be the power that you multiply, which will give you a raised to the power 6. So that being said, applying that rule here, you can say that um, this thing can be in form of this. So from here, you can now say, let y represent x squared. If y represents x squared, we have 4y squared minus 17y plus 4 equals to 0. Cooler. So something like this now is in form of the quadratic equation that I taught you, which is a x squared plus bx plus c equals to 0. So you can now say that your a is 4, your a is 4, your b is minus 17, and your c is 4. So if you actually want to use formula method, and what is that formula again? Formula for quadratic equation is x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. You can use this formula, or you can use your calculator, or you can use your factorization method. Any of the method that you're comfortable with, you can just do it. So for example now, by the time I solve this, by the time I solve this, I can actually use factorization method to solve it, but I just give the answer. You go and do the other one by yourself. So we are going to be getting y to be equals to 1 over 4 and y to be equals to 4. So if you are getting your y to be 1 over 4 and 4, remember we said that x squared is equals to y. So, and if y is 1 over 4, you now have x squared will be equals to 1 over 4. Now, for you to get x, what do you do in mathematics world? You square root both sides. When you square root both sides, you have x is equals to square root of 1 over 4. And square root over 1 over 4 will give you 1 over 2. So that is that case. So, and in this one, when y is x squared is equals to y, and y is equals to 4, then x squared equals to 4 square root of x squared, x is equals to square root of 4, and x is equals to 2. So remember, whenever you square this something, the answer is plus and minus 2. So that is the first answer we are going to get when you apply this particular question to solve. Now let's look at another example. Look at an example. This particular example, um, another way or the complex quadratic can come out is in form of this. But this particular one is actually very easy because they already told you what to do. They say use the substitution y is equals to x to the power 1 over 3. Look at the question. The question is 3x raised to the power 2 over 3 minus 5x raised to the power 1 over 3 plus 2 equals 0. This is another complex quadratic equation. Now, I can also simplify this to be like the second one. What do I mean by that? It's something as 3x raised to the power 1 over 3 in brackets square minus 5x raised to the power 1 over 3 plus 2. So now, what is inside here at this one are what they ask us to use to substitute. So if I substitute y now, I have 3y squared minus 5y plus 2 equals 0. Now, this is a simple quadratic equation. This is a simple quadratic equation. Now you can solve this one. You can also use your factorization method to solve it, or other form of method. If I use factorization method to solve it, you are going to get 3 y minus 2 and y minus 1 equals to 0. You don't know how to get this, go and watch my other videos. Yes. So you now have y is equals to 2 over 3 and y is equals to 1. But remember that we said that the substitution is x raised to the power 1 over 3 is equals to y. So you now have x raised to the power 1 over 3 will be equals to 2 over 3. And for you to remove 1 over 3, you have to multiply both sides or cube both sides. Yes. If I cube both sides, I will have x raised to the power 1 over 3 cube is equals to 2 over 3 cube, which will give me x is equals to 8 over 27 on this part. While on the other part, when I have x raised to the power 1 over 3 is equals to 1, x is equals to 1. That will be my answer for these two complex quadratic. Let's look at another example again. Two more examples. So this particular one, how do we solve this one? This one looks really complex when you have x minus 4 with x minus 21 equals 0. So how do you do it? Now I'm going to show you something in this case. Now look at this. Square root of x is the same thing as x raised to the power 1 over 2. Okay? Yeah, then yes. Then if y is equal to x raised to the power 1 over 2, x y square will now be equals to x. Let me explain this, because you need to understand this concept to help you to understand it. So x, y raised to power, y is equals to x raised to power 1 over 2, which is square root of x. So at this case, if I want to remove the square root, I will square both sides. Let me explain it the way you now understand. Okay, I will say um, uh, let me start it from the beginning. I will say let y to be equal to square root of x. If y is equal to square root of x, then then x will be equals to y squared. Because for me to get x, I'm going to square root both sides in this case. I'm going to square both sides. By the time I square both sides here, I will get my, let me do it the other way so that you understand it better, so that I understand it better. When you have y squared, we now be equals to x. That means we squared both sides. So applying this in our work now, our yx is going to be y squared minus 4y minus 21 equals to 0. So when you have it that way, it's in form of quadratic equation that you are so familiar with. So here now, you can now factorize it. If you factorize this, you're going to have y minus 7 and y plus 3 equals to 0. That means that your y equals 7 and your y is equals to minus 3. So if you remember, your x is, your y is root x. Your y is root x. So if your y is root x, so x will now be square of y. So what will that do if root x is equals to, if root x is equals to 7, x will now be 49. The same thing is applicable here. If root x is equals to minus 3, looking at this is not possible because square root can give you a negative. So you have to stop here. If you give you a negative, that means you give equals a negative anyway. If you are able to get only negative, that means something is wrong with the complex number. So this is not valid for this. We now pick up this one. One more question, and we are done with complex quadratic. Now let's look at this. This particular one, we are not told what to do. So what do you do? 8 in bracket 4 raised to power x minus 33 in bracket 2 raised to power x plus 4 equals to 0. I can make this to be in form of 2x also. The same thing as 8 in bracket 2 raised to power 2x minus 33 in bracket 2 raised to power x plus 4 equals to 0. If I move on, I'll have 8 in bracket 2 raised to power x raised to power 2 minus 33 in bracket 2 raised to power x plus 4 equals 0. So you can now say let y is equal to 2 raised to power x. And if that's so, then you have 8y squared minus 33y plus 4 equals 0. Now this is your regular quadratic that you can now solve. If we use factorization method again, we'll be having 8y minus 1 and y minus 4 equals to 0. That means that your y equals to 1 over 8 and y equals to 4. So if that is the case, 2 raised to the power x, remember 2 raised to the power x is equals to 1 over 8. And the law of indices, 2 raised to the power x is equals to 2 raised to the power minus 3. That means that x is equal to minus 3. And in this case, 2 raised to the power x is equal to 4. 2 raised to the power x is equal to 2 raised to the power 2. And x is equal to 2. Very easy to work on complex quadratics. So all you need to do is just to follow the format. The other question, and by the time I'm done with this topic, I'm going to go to a past question and we solve questions that relate to this. But for now, follow this, look at the example over and over again, and try other past questions yourself. Thank you for listening. Remember to watch and subscribe and like video also. Well done.